afternoon, Dr. Ken here with you again. This is AC Lesson 12, Part 3. We're looking at measuring the active and active earth impedance and comparing it to a resistance table in AS 3017 Table 3.2 is our method. Just to recap, our previous first method was to measure the fault loop impedance with a earth fault loop impedance meter. The second was to calculate the maximum length allowable and then compare that again to some tables in AS 3000 and make sure our cable length was shorter. Our third method is to measure the active and active earth, well, not so much the impedance, but its actual resistance. So let's have a look at that. So here's a table we'll be using, table 3.2, and you've got to remember we're only measuring resistance, and this table gives us resistance measurements against different sizes of active earth and a protective device. So in the example we'll work through in a moment, let's say we have a protective device at 40 amps, an earth at 2.5 square millimeters, and a active at 6. So some special notes: it's only the cold resistance, it's only for the FFC, sorry, the FSC, as I said that correctly, and there are still some holes. This is not the most perfect way to do it, but it gets you a reasonable approximation. So here's what our circuit looks like, and I'll just describe it for you. We'll have our substation, of course, with our good old star connected transformer, pad mount or pole mount sub, and of course the neutral will get connected to here. The active will come through the supply authorities network and get connected here. There'll be some kind of protective device, of course, at your switchboard, normally a HRC fuse. Then you've got a main switch. So this is your main switch here. And then your circuit breakers, your protective devices are here. Just drawing in a couple of those. And what we've done effectively here in this circuit, we've taken one of those, we've pulled the tail out of the bottom here. And we've taken it to a multimeter. So we still have an MEN. So here's our MEN connecting the bond between the earth bar and the neutral bar. So we've taken the tail out, we've connected one end of the tail to a multimeter to measure resistance. We've put a link of some kind in here, a link between active and earth. Then we're coming back along the earth conductor. We've also pulled that out of the terminal strip. So we know that we're only dealing with the earth for the final sub-circuit and the active conductor for that final sub-circuit. And you must have this link installed. And basically we measure this resistance on our multimeter on the ohms scale, obviously. And let me tell you, you'll need a good quality multimeter, and you'll have to make sure you zero it well, because your ohm reading will be low. So you're wanting to measure a very low value of resistance. So your resistance. So the multimeter you use for this has to be a really good quality multimeter. So coming back to our table, As I said before, we're going to have a 6 square millimetre active for our example, a 2.5 mil earth, and our circuit breaker is rated at 40. Therefore, if we go across and we assume that our circuit breaker is a type C, then here's the area that we must be interested in. And our resistance for the phase and the protective earth is this one. If we're only measuring the phase or only just measuring the earth, it would be those two. Therefore, we must come in under this value here. So we must come in at under 0.5 of an ohm. So if our multimeter has not read less than 0.5 of an ohm, less than half an ohm, then the circuit breaker will not trip, and you will have to do something about it. So either reduce the length or up the cross-sectional area of the conductors in the circuit. They're the only two options in this particular sense. So that's how we use the table. You can just measure the cold resistance and work out what the resistance is and compare it to this table. And as long as you stay under what the table says as far as resistance goes, your circuit breaker will trip.